So here we have a very special type of series. Now let's try to understand the first term here. So here we have 1 over a multiplied to a plus d. Now this is a single fraction, but what we can do, we can decompose into two partial fractions. If we consider 1 over d as the common factor, and to it we are going to multiply 1 over a minus 1 over a plus d. So we can verify that. So when we combine the two terms within the parentheses and multiply with 1 over d, so that's going to give back the first term. Now coming to the second term here, we have 1 over a plus d multiplied to a plus 2d. Now here a is the first term of an arithmetic sequence and d is its common difference. Now this second term can be also expressed, since it's a single fraction, we can again decompose it into two partial fractions. We have 1 over d. To it we are going to multiply 1 over a plus d minus 1 over a plus 2d. So here we have decomposed the given second term into two partial fractions. Similarly, we come to the third term. We have 1 over a plus 2d multiplied to a plus 3d. So this can be again broken down as 1 over d multiplied to 1 over a plus 2d minus 1 over a plus 3d. Fine. Okay. Now we come back to the last term. So here we can use the same logic. So we have a plus n minus 2 multiplied to d. So this is getting multiplied to a plus n minus 1 times d. Fine. So this is going to be equals to a 1 over d. To it we are going to multiply 1 over a plus n minus 1 times d minus 1 over a, this is n minus 2, a plus n minus 1 times d. Fine. Now what we'll do, so this is our first term. Let's label this as number 1. Second term is 2. Then we have the third term going all the way up to the nth term. So what we'll do, we're going to add all of these terms. So when we add all of these terms, that's going to give us the sum to n terms of the given series. So let's do that. So here we have replace each of the terms. Now what we'll do, we're going to take 1 over d as the common factor from each of the terms. Now here we will observe that negative 1 over a plus d and positive 1 over d gets cancelled off. Next we have negative 1 over a plus 2d and positive 1 over a plus 2d gets cancelling out. So all the terms will get cancelled except for the first term, which is 1 over a, and the last term, that is negative 1 over a plus n minus 1d. Now that means we are now left with 1 over d multiplied to 1 over a minus 1 over a plus n minus 1 times the common difference d. So this is going to be the final sum to n terms of our given series. Let's try to understand this with the help of an example. So here we need to determine the sum to n terms of the following series. Okay, let us begin. So what we'll do, we'll start by first considering the nth term of the sequence, but we'll not consider the nth term, but we'll consider the rth term. So let's suppose that tr represents the nth term or the rth term of the given series. So all we have to do is replace the n value with r, so such that we get 1 over r multiplied to r plus 1. However, what we'll do, we are going to decompose it into two partial fractions such that we get 1 over r minus 1 over r plus 1. So here we can simply verify that. So if we combine these two, we'll get back 1 over r times r plus 1. Now, reason why we considered the rth term instead of the nth term, because in order to find out the sum to nth term as n, we'll be taking help of tr. That means we'll take the summation of the rth term such that the index r goes from 1 to n. In other words, what we have to do is find out the summation of 1 over r minus 1 over r plus 1 with r going from 1 to n. Fine. Now, what we'll do, we'll use r equals to 1 to get the first term. So that's 1 over 1 minus 1 over 1 plus 1. So that's going to be 2. Added to the next term. To find out the next term, we'll replace r value with 2. to get half minus 1/3. To get the third term, we're going to get 1/3 minus 1/4, replacing r value with 3, and this is going to continue all the way up to 1 over n minus 1 over n plus 1. That's going to give us the nth term. Now we can observe here that the second, third, fourth, fifth, sixth, seventh, all this term gets cancelled, leaving us with the first term and the last term. That means we have 1 minus 1 over n plus 1. So if we combine them, this is simply going to give us n over n plus 1. This is going to be the sum to n terms of our series given by 1 over 1 times 2 plus 1 over 2 times 3 and so on. Let's go to the next problem. So here, example number 2, we need to determine the sum to n terms of the following series. So what we'll do, we'll first try to figure out the nth term of the series, but instead of the nth term, we'll find out the rth term. So let's suppose that tr represents the rth term of the series. So tr, that will be given by 1 over. Now here, if we consider the first term of the denominator, which is 1, then in the second term we have 3, next we have 5. We have 1, 3, 5. Now clearly this is an arithmetic progression with first term being 1 and the common difference being 2. So we can find out its rth term. So the rth term will be given by, we have a plus r minus 1 times the common difference d, which means we have 1 added to r minus 1 times the common difference 2, and that's going to give us 2r minus 1. So we have 1 over 2r minus 1. This is going to get multiplied to, now what we'll do, we'll consider the second term of each of the values in the denominator. So starting with 3, we have next 5, then 7. Now clearly this is also an arithmetic progression with first term being 3 and the common difference being 2. So this is going to have an rth term given by, we have the first term 3 added to r minus 1 times the common difference, which is 2. Now when you simplify this, we're going to get 2r plus 1. So that means we have 2r plus 1, and this is going to be the rth term of the series. And furthermore, what we can do, we can again decompose it into two partial fractions. So we have 1 over the common difference, which is 2 here. So this is going to get multiplied to 1 over 2r minus 1 minus 1 over 2r plus 1. Fine. So we have successfully obtained the rth term of the series. Now we are ready to find out the sum to n terms. The sum to n terms will be given by summation tr. Now r is an index that's going to run from 1 to n. In other words, we need to find out the summation of r going from 1 to n. We have half multiplied to 1 over 2r minus 1 minus 1 over 2r plus 1. Okay, next what we'll do, we're going to expand the summation. So for the first term we have half multiplied to 1. So we are replacing r value with 1. So we have 1 minus 1 over 3. Then we have the next term given by half multiplied to, we'll replace r value with 2 such that we get 1 over 3 minus 1 over, so 2 times 2, that's 4. 4 plus 1, that's going to be 5. Next, this is going to continue all the way up to the last term, which is going to be given by half multiplied to 1 over 2. Now we are going to replace the r value with n, 2n minus 1 minus 1 over 2n plus 1. Now what we can do, we can take half as the common factor, and we will see that some of the terms will get cancelled out, and that's going to leave us with the first term, which is 1, and the last term, which is negative 1 over 2n plus 1. And we can combine it. So combining it is going to give us the final sum. Thus, Sn is going to be given by n over 2n plus 1. So that's how we can determine the sum to n terms of the series, which is given by 1 over 1 times 3 added to 1 over 3 times 5 and so on. Okay, let's go to the third problem. So here we need to determine the sum to n terms of the given series. Okay, let us begin. So we already have the summation given to us. So we have summation with r index going from 1 to n. We have the rth term given by ar plus b. This is multiplied to ar plus a plus b. Now what we'll do, we'll try to decompose this fraction into two partial fractions. such that we get summation r going from 1 to n. So let's try to do one thing. We'll take the first fraction as 1 over ar plus b. And from it, subtract 1 over ar plus a plus b. Now when we combine both of them, we'll see that there will be an extra term in the numerator, which is going to be a. So we have to get rid of that numerator because it only has to be 1. We are going to multiply throughout with 1 over a. Fine. So now that we have simplified the summation, what we'll do, we'll try to expand it. So the first term is going to be 1 over a multiplied to 1 over, so we have to replace r with 1. So that gives us 1 over a plus b minus 1 over, we'll get 2a plus b. Fine. Next, we have 1 over a multiplied to, this is going to give us the second term replacing r with 2. We have 1 over 2a plus b minus 1 over 3a plus b. So this is going to continue, and then we have the nth term. We have 1 over a multiplied to 1 over an plus b minus 1 over an plus a plus b. Fine. Okay. Now, if we take 1 over a as the common factor from each of the terms, we have 1 over a plus b minus 1 over 2a plus b added to 1 over 2a plus b minus 1 over 3a plus b, and this goes on to 1 over an plus b minus 1 over an plus a plus b. Fine. So here the second, third, fourth, fifth, the second last term all will get cancelled out. That is going to finally leave us with 1 over a multiplied to 1 over a plus b minus 1 over an plus a plus b. Now if we want, we can combine them or we can leave it as it is. So this is going to be the sum to n term. So let's try to combine them. That I'm leaving as an exercise for you to try out. So the final sum after combination comes out to be as n equals to n over, we have a plus b multiplied to an plus a plus b. Fine. So we have talked about how to find out the sum to n terms of a very special type of series, which is of the particular format.